Okay, we're going to take a look at the calculus paper 3F. It's quite a tricky question, very tricky question actually. And you have to really use this whole idea around AB being a point at the tangent and the curve. And again, this kind of relates back to one of the other questions where we were talking about when is a line a tangent to a curve, and it's a tangent to the curve when it touches it at one position, and when it's when the slope of that line is equal to the derivative, basically, at that point. And so we've talked a little bit about this already. If I'm going to make AB a point on the parabola and the line, then I can rewrite the equations. So let AB be a point on the parabola where the line y is equal to px plus 3 pi is a tangent. If that is true, then we know that AB is a point on the parabola. So we can just stuff those in for x and y, and we'll rewrite the equation. Instead of y, we'll put a b. Instead of x, we'll put an a. And basically, we want to get these equations in terms of the point, in terms of a and b, so that we can solve and find p. All these questions where you've got unknowns and so on is about basically trying to get an equation or an expression in terms of a common thing. Now, the other thing is, if AB is a point also on the line, and again, I think it's very useful to draw pictures of things and get a sketch of the equation and maybe a reasonably accurate graph because you've got the full equation, and to get a sense of where that tangent line, if it's going to have a y-intercept of 3.5, right, where it's going to come, what side of the vertex and so on it's going to hit. It makes sense that it's going to hit to the left of 4 and -9 because that's the vertex of the parabola. So we've got AB as a point, right? AB is going to be the point. And so that means that we can write the line in terms of AB as well. And so instead of y and x, we're going to use b instead of y is equal to p times a plus 3.5. So now we've got the first equation and the second equation in terms of a and b. Now, we haven't done any calculus yet, basically. So the next thing is, where does the calculus come in? Well, we know that the point AB is also a point at the derivative of the parabola, right? Because that's what the tangent does. It tells us what the gradient is. So it basically is going to tell us it's going to be a point at the derivative of the parabola. So we've got to do the derivative of the parabola, which is 2x minus 8. And then again, because the a and b is going to be a point on that, we make the equation in terms of a and b. So b is equal to 2a minus 8. Now at this point, we've got just a's and b's in here, and just a's and b's in here. We can do algebraic substitution and solve for a and b. So we do simultaneous equations. We basically substitute in instead of doing elimination. We just substitute. And when we do the substitution, we're going to end up getting an equation. So we do the b is equal to 2a minus 8, and we substitute that in for the b here, and we get this expression. And when we solve that and work it around, we get this. When we solve that, we get two answers. Sorry. We get two answers. We get 1.84 or 8.16. Now, both of these answers can't be right and can't be used. So although this simultaneous equations gives us two answers, then we've got to make a decision about which one of those makes the most amount of sense. So if we go back in here into our diagram with a line that has a y-intercept of 3.5 and the vertex is 4 and -9, then the only answer that makes sense here is the smaller number, the 1.84. 8, 5, 6, 7, 8. 8.16 would be over here somewhere. And we know that the tangent can't be there if it's going to have a y-intercept of 3.5. So it can't be both. The easiest thing to do is look at the drawing situation, look at the graph, which is a vertex of 4 and -9. And the only logical solution is 1.84. Then you just simply take that 1.84 of a and you can substitute it in one of the equations that we were using earlier, like the b equals equal to 2a minus 8, and find out what b is. And then now that we know what a and b is, we can substitute that back into the equation up here, which has a p in it. Where is it? We can substitute it in up here, and then we can find what p is. And p is negative 4.25.